we've learned all these ways of doing linear systems of equations. Now we're going to learn how to apply them. So first thing we need to talk about is a couple of definitions. One is the break-even point, and this is the point at which the income of a business equals the expenses. This is the point that after you hit it, you start to enjoy owning a business because you're making money. Another thing is uniform motion, and this is where an object moving at a constant rate of speed. These are two examples of times when you would use systems of equations to solve problems. So let's look at some examples of these problems. Okay, so here's a break-even problem using systems. Suppose you have a typing service. You buy a personal computer for $1,400 on which to do your typing. You charge $5.70 per page for typing. You must pay 70 cents per page for ink, paper, electricity, and other expenses. How many pages must you type in order to break even? Okay, remember, your break even is your equation for expenses, and it's going to equal your equation for income. X is going to equal your number of pages. We're going to let Y equal your income and your expenses. So what are your expenses? Your expenses are the $1,400 you're going to pay for your computer, and your 70 cents you pay per page. So our equation for Y would be Y equals 0.70x plus 1,400. So this is one equation. Then we need to write another equation that represents income. Well, we make $5.70 per page. So we can say for our income, Y equals $5.70 x. So here's my two equations. Okay, remember, we're looking for how many pages do we want to type to break even. Okay, so still talking about the same problem. Remember, equation for expenses equals the equation for income. X equaled number of pages, Y equals income or expenses. We had this equation that represented our expenses, and this equation represented your income. Okay? So this one's kind of simple. You can set it up as 0.70x plus 1,400 equals 5.70x. Now, we can subtract 0.70x from each side, and then divide. We get 1,400 equals 5x. If we divide both sides by 5, we find x equals 280 pages. So once you type 280 pages, you're going to hit your break-even point. That answers our question. How many pages must you type to break even? So after you hit this, you're going to start making money. Make sure when you're working with break-even problems that you actually answer your original question. So keep the original question in mind as you go. So in this case, I didn't have to set up the traditional system of equations, but I had to set two equations and make them equal to each other. I used substitution in this case because I had this, and I was able to substitute this value in for Y. Okay, so what if we want to do a uniform motion problem using systems? So let's think about the distance formula. And I know we've talked about distance formula as the square root of x1 minus x2 squared plus y2 minus y1 squared. I'm not talking about that distance formula. I'm talking about this distance formula. More sciencey version, where we say distance equals rate times time, where d equals distance and r equals rate and t equals time. Okay, the rate can be affected by wind, or speed, or water, or wind current, and wind or current can increase or decrease the rate. So here's why I'm giving you this. All right, so for example, if we're in a fishing boat, it's going to travel 30 miles in 1.5 hours down the river. Down, I'm going to say stream. All right, the return trip takes 2 hours. Find the rate of the boat in still water. Okay, so when we go downstream, we travel 30 miles in 1.5 hours. Then when we come return trip, which means we're going upstream, it takes 2 hours. We want to find the rate of the boat in still water. So here's what we know. Downstream, the current increases in rate. So we have rate plus current. Upstream, current decreases in rate, so we have rate minus current. So you've got to keep these two things in mind. So let's look at what kind of equation do we want to set up. Okay, so downstream, we're looking at we're traveling 30 miles at a time of 1.5 miles, and our rate is R plus C. When we're going upstream, we're still going 30 miles, but it took us longer. It took us 2 hours, so our rate is R minus C. Remember, the distance formula is R times T. Okay? So we have our D, our T, and our R for both. So downstream, our equation would be 30 because that's how far we went, 30 miles, equals R plus C because that was our rate, times time. Remember, this is your formula. Upstream, our equation would be 30 equals R minus C because that's our rate, times 2 because it took 2 hours. So if we set this up, we have 30 equals R plus C divided by times 1.5. We want to isolate our variables. So if we divide both sides by 1.5, we get 20 equals R plus C. On this side, to isolate the variables, we divide both sides by 2, we get 15 equals R minus C. This time, we're going to use elimination. So in the break-even problem, we were able to use substitution. This time we have to use elimination. Fortunately, it's going to be the easy way of elimination because we have a plus and a minus, which means that our C's are inverses. So, when we add these, our C's will cancel, telling us that 2R is equal to 45 because R plus R is 2R and 20 plus 15 is 45. Divide both sides by 2, we find our R, which is really all we need, to be equal to 17.5. So what that tells us is that our rate is equal to 17.5. And the question was, well, what was our question? Our question was the rate of the boat in still water. What is the rate of the boat in still water? And the answer is 17.5. So these are two applications of systems of equations, but don't worry, there's many more.